Hey guys, in this video we're going to look at the ANOVA two-factor without replication. And once again, the ANOVA, or analysis of variance, looks at the variance instead of the sample mean, which a t-test would do. So in this example, I gave the sample problem here. You are a drill sergeant for phase 2 of basic training for the Marines on the East Coast. You've trained new recruits, and now they're being tested in 3 different events: swimming qualification, rifle qualification, and team qualification. Each recruit is tested in all 3 events, and all events are scored out of the maximum of 35. So what can you conclude from the results of this test? So once again, it is very important to notice what the question is asking and how the data set is laid out. Last time, in single factor ANOVA, we looked at 18 different people, each doing their own thing, right? This guy is doing the drug X test. This guy over here is doing the drug Z test. And they're not doing something, they're not repeating tests, and they're not doing a different test. But in this scenario, we have 6 different guys, right? 6 different guys. So each guy is doing all 3 tests. Each recruit is doing all 3 tests. So that's where the two-factor or multiple factors start coming in. Okay, so we're going to do the data analysis. Make sure you select the ANOVA two-factor without replication. Click OK. And the input range here, you want to select the entire thing, including the recruit names 1, 2, 3, 4, and 5, and 6. Right? I have labels. I like labels. Alpha 0.05 is good. Output the data nearby. Click OK, and here we go. So once again, the summary up top is more of a descriptive statistic. Sorry, and the bottom here is more inferential. So how do we read this output here? Well, on top, it talks about the sum, the average, and variance, so on and so forth. And it also shows you this by the individual recruits. And it also shows you the different factors, or in this case, the qualifying tests that the recruits have to take. So now we move on to the inferential part. And here it says rows. Right? In the first one, it says rows, and you notice that the F value is smaller than the F critical. The P value is greater than 0.05, and that's basically saying, well, each individual guy's performance compared to any other guy's performance on the team or whatever is not very different, right? If you eyeball the data set, people tend to do pretty okay on the first one, a little bit poor on the second one, and pretty good on the third one. And so this trend within itself between the recruits, there is no statistically significant difference. However, if you look at the columns over here, you notice that there is a statistically significant difference. F is greater than F critical, P value smaller than 0.05, so on and so forth. And this it is confirmed if you look at this descriptive part here. You can see that the average for the swimming qualifying test is 20, but the rifle qualifier is only 11.5, and then it goes back up to 24 for the team qualifier. So on the answer page, I said that, well, you can tell that from the data set that recruit number 4, based on the descriptive, is the best guy. Right? He's the best guy on the team. However, there's no statistically significant difference between the recruits. There is a statistically significant difference between the 3 tests. And looking at the mean of the test, we can see that the rifle qualification scores are on the low side. So we can conclude that either the rifle qualification, right, is significantly too hard, or the Marines are significantly underqualified, right? They can't shoot. So this is why I said, either the tests are too hard, or the Marines should just be lifeguards instead, right? All right. So this is the 2-factor without replication ANOVA test. I'll see you next time in 2-factor with replication, and you can sort of see the difference between these 2 tests. And that's it for this one. I'll see you next time.